Okay, so now we're leaving the stomach and we're entering the small intestines. So the function of the small intestines, the main function is going to be to finish chemical digestion, and it's going to absorb. Okay, so it's the place where we're absorbing all of our nutrients, our electrolytes, and the water. So the small intestines receives 9 to 10 liters of secretion, food, and water in a day. Okay, our food spends about 12 hours in our small intestines. So it's going to be broken down and the nutrients are all going to be absorbed. Okay, so the parts of the small intestines, so I always say remember D, J, I. So D, J, I. So the duodenum is the first part, then the jejunum, and then the ileum. So the ileum is the last part before we get to the large intestines. So the ileum is connected to the large intestines by the ileocecal valve. Let's see. The accessory organs, the liver, the gallbladder, and the pancreas are all going to dump their secretions into the small intestines. Okay, now the gross anatomy of the small intestines. So the duodenum, some people say duodenum, either one is right. Okay, it curves around the head of the pancreas. It's about 10 inches long. So it's retroperitoneal, so it's behind the peritoneum. The duodenum is the first part, so that means it's going to receive the stomach contents, it's going to receive the secretions from the pancreas, and it's going to receive the bile. Okay, now what's going to happen is it's going to neutralize the stomach acid. So we don't want the pH to be 2 to 4. We need it to be closer to 6 or 7. Okay, it's going to emulsify fat. Okay, so emulsify means we're going to take big globs of fat and we're going to break them down into smaller globs of fat so that they can be digested by enzymes. And then we're going to inactivate pepsin. Okay, so pepsin gets turned off. And then it's also going to receive the pancreatic enzymes. So there's a bunch of enzymes that are released from the pancreas. Okay, so duodenum is important. Okay, the jejunum is the next 8 feet. Okay, so it's in the upper part of your abdomen. It's where chemical digestion is going to take place and absorption is going to take place. So the nutrients are going to get put into the bloodstream. Okay, the ileum is the last 12 feet. It's in the lower abdomen. It's mainly for absorption. Okay, and I already said this. It's ends at the ileocecal junction, so that's where it connects with the large intestine. The small intestine has a huge surface area. So it's got lots of things that are going to increase its surface area. It has circular folds, which they used to call plicae circularis, so sometimes you'll see either one. So it's got circular folds in it. So if you took it and stretched it out, you're going to see all these folds kind of going back and forth like this. And they're about a centimeter tall, so 10 millimeters tall. They only involve the mucosa and the submucosa, and what they're going to do is they're going to kind of direct the chyme as it comes through, so it kind of spirals through and contacts the small intestine as much as it can. So it kind of like sends it down like a half pipe where it's going woo and it's spinning around. Okay, now the small intestines, the circular folds on them, they also have villi. So these are about a millimeter tall. They have, so here's the villi. They have blood vessels, and then they also have lymph vessels that are called lacteals. These are going to be where absorption takes place. Okay, so you can kind of see here. Here's the villi. Okay, and then here the green is the lymph, is the lacteal, and the you can see arterioles and venules in there. Okay, now on the villi are microvilli, and they're just a micrometer tall. So they call them a brush border on the cells. So if you have the cells, on top of the cells you have this. Okay, so the brush borders are the places where the last bits of digestion take place. So if you could put your hand in somebody's intestines, it would kind of feel maybe like velvet. It would be so much surface area, almost like little tiny hairs. So all of that surface area is there so that you can digest and absorb your nutrients. Okay, now, intestinal crypts are pores that are between the villi. Okay, so these are intestinal crypts. And in them, we have these glands that are called Brunner's glands. They secrete bicarbonate. Okay, so the idea is they're going to increase pH. Okay, so remember this, the pH from the stomach is 2 to 4, so we want it to go up. We don't want it to be that low when it's in the small intestines. Okay, now out in here, we're going to find Peyer's patches. So they're lymphocytes. So they're clumps of lymphocytes that are there to fight pathogens that might be getting through to the small intestines. Okay, now we also have secretion going on. So 1 to 2 liters, the pH is 7.4 to 7.8, and it's got water and mucus in it. Okay, so here's another image that shows you what the circular folds look like. So the book, I think, describes them as speed bumps. Okay, but here's the circular fold. Okay, and then there's the villi, and then on the villi are microvilli. So it's just layer upon layer of like little fingers. So just think velvety, like just tons and tons of little brushes. And the idea is they're going to increase the surface area for digestion and absorption. Okay, now the intestines, oh, this is weird. It's kind of down. I don't know. All right, so the intestines, so 3 reasons why the intestines have to move. Okay, so one is it's got to mix the chyme with the stuff that's coming from the liver, the pancreas, and the gallbladder. Okay, so the chyme has to mix with them. Okay, now it also is going to churn the chyme, so it's going to spin it around, so it actually contacts the mucosa. So when it contacts it, that's where a lot of digestion occurs and where absorption occurs. So if it's not touching it, you can't get anything out of it, and you can't break it down. Okay, now the third reason is we need to move things along, and we need to get into the large intestine so we can get rid of the waste. Okay, now there's 2 types of movement. Okay, so one is called segmentation, and the other one is peristalsis. So segmentation is, if this is your small intestines and it's really long, segmentation is segments of it kind of contract, and they just mix, kind of push the chyme back and forth. Okay, so it goes back and forth. They say it happens 12 times per minute when it's in the duodenum, that we have this segmentation that's moving things through. Peristaltic waves, okay, that's when we're moving it one direction. Okay, so it pushes the chyme around, along. Okay, and they say it takes 2 hours, right? So it pushes it through. They usually go through these haustral segments. The food in the stomach causes a gastroileal reflux, and we're going to talk about that when we get to defecation. So gastroileal reflux is the food passing from, or the chyme passing from the small intestines to the large intestines. So think about if you've ever had a baby, when they're really, really young, the gastroileal reflex is really strong. So as soon as you feed them, they poop. Okay, so they get something in their stomach, the stomach stretches, and that causes the food to get pushed from the small intestines to the large intestines. So it's like you get them back to sleep and then they poop. But we'll talk about that more. Okay, so here's segmentation. Okay, so segmentation is just, if you follow this like brown, so the brown is just kind of mixing back and forth. This is mixing back and forth. back and forth. Okay, and then we might mix it between two other segments. Okay, so we're not moving things along, we're just churning it. Okay, because we want it to touch the walls of the small intestines. We want it to touch that brush border. Okay, now peristalsis is this wave-like movement. Okay, so wave-like movement is going to move, so we're going to constrict, and then the longitudinal muscles are going to push, and then we're going to constrict, and then we're going to push. So, so gradual movement of contents towards the colon, which is the same as the large intestines, begins after absorption occurs, and then there's a motor complex in the intestines that's going to control the waves. Okay, so the second wave is going to start at kind of at the end of where the first one was. Does that make sense? So distal. So we're not like starting up here at the beginning every time. This one starts distal to where this one began. Kind of think of it maybe as pushing toothpaste through. But that's peristalsis.